Hello everyone. I set myself the goal of inventing and implementing a technology for creating ultra smooth, self-leveling walls that anyone can easily make, even without any construction experience. It appears I've devised the plan and have begun executing it. Well, look at this, isn't it a miracle? And the quality, just look at the quality. This is my first time doing it. The surface of these walls is immediately ready for painting, and that's the highest level of finishing, and it doesn't require any special skills from the workers at all. The laws of physics are working for us. Everything is done right at the stage of building the walls. The most affordable construction materials are suitable. The first thing I did was dive into studying the method of making self-leveling poured floors. I'm working according to the instructions, so first I carefully prime the experimental floor sample with a deep penetrating primer, since the experimental floor sample is located in my laboratory's under canopy space. As we can see, it doesn't have any walls around it. To prevent the self-leveling floor from flowing off this surface, I framed the floor with borders made from scraps of polystyrene foam. I spent a long time studying self-leveling floor mixtures, and I admit, this text here really convinced me. Self-leveling floor for people of any skill level, just the way I like it. The first lines on the back of the Berghoff Easy Bowden package say that this is the easiest floor to use. It speeds up the work and simplifies the choice of materials. It's written in blue on white that this is a unique product recommended for people of any skill level, including beginners. From the instructions, I learned how to check if the base is ready for pouring. You need to pour water and wait 30 seconds. If it doesn't get absorbed, then everything is fine. If it does, it means the surface is highly absorbent and needs additional priming. By visually assessing the unevenness of the floor surface, I roughly estimated how much mix I would need. The surface area is small, so I prepared the required amount in one batch right away. From the tools I didn't have at home, I'll need a spiked roller to roll out the self-leveling floor in order to get a smooth and even surface. Its spikes should be 5 to 10 millimeters longer than the intended thickness of the layer we want to pour. To avoid straining my back, I pour a portion of Berghoff Easy Bowden into a smaller bucket. I pour it onto the floor and spread it out with a wide spatula. The floor area is 4 square meters, which is the size of an average bathroom. I'm a complete beginner when it comes to self-leveling floors, but I already like how it's turning out from the very first seconds of work. I roll the smooth surface with a spiked roller, and it turns into an ultra-smooth surface. It's nothing short of a miracle, and almost effortless too. I pour the next batch of the substance into the bucket, and its consistency is similar to thick sour cream. I pour it onto the surface again and feel like a person who's touched the wonders of modern technology. The creeping mass immediately gets to work, leveling the surface with a spatula. I help it just a little, guiding its work in the right direction. I want to keep doing this process forever, but Berghoff Easy Bowden seems to be specially designed to spend less time on leveling and to finish this stage of work faster. In real conditions, when there are walls in the room, it's best to fix a damping tape along the walls. It's needed as a compensator for linear deformation. The risk of the floor cracking will then be minimized. Just started and already finished. It's even a bit of a shame. Easy Bowden, the spiked roller, and the gravity of our planet work wonders. The roller not only levels the surface, but also removes air bubbles from the mixture. Some bubbles disappear on their own, but it's a very pleasant and rewarding job with a 100% effect. If I were pouring a large area, I might need a partner to ensure a steady supply of new batches. But I did everything myself, and why didn't I think of using self-leveling floors in construction before? Well, I don't know. Live and learn. By the time I washed the tools, the shine was gone, and the matte surface stayed perfectly smooth. The floor starts to set in 4 hours, and after just 8 hours, I'm already walking on it in my wide slippers. A strength of 12.5 megapascals is equal to grade M100, and that's enough both for the floor and for what I have in mind. To the touch, the surface is just as smooth as it looks. The hardened Berghoff Easy Bowden doesn't produce any dust at all. I recently found the most precise way to describe my method for my ultra-affordable construction project, a frame panel house. Let me briefly refresh your memory about the frame, as I'll provide more details on the walls later. To achieve record savings, I made extensive use of pseudo-timber. To make pseudo-timber, you need 1-inch boards, long screws, and a drill driver. I place the boards next to each other like this. I mark the holes for the screws every 15 centimeters. If the boards are warped, like mine, I first drill a couple of holes at the beginning and end, then I screw them together. Then, in the center, you can correct the board's warping with a clamp, and I screw in a couple more screws. I'm used to working with the bare minimum of tools, but I think a drill driver is definitely on the list of absolute essentials. Then I drill pilot holes and screw in the remaining screws. If the drill driver is good, the boards will fit together tightly, leaving no gaps. Recently, I acquired an 18-volt impact drill driver, which is certainly not a plaything. In the case, there's the drill itself with a battery. There's a second battery as well, both 5 amp hours each. You can screw indefinitely. It has a cool charger and batteries with charge indicators. Features include a reliable metal keyless chuck, brushless motor, belt attachment, and an included holder and bits. 2 boards are screwed together. This is how I put the third one in place. 24 torque clutch settings for precise screw driving. Drilling mode. Hammer mode. In the AID drill driver, the rotation speed is controlled by the pressure applied to the start button. This allows you to work comfortably with different materials. Drilling again, screwing again. As you already understood, the main work when making pseudo-timber is warming up with a drill driver. The third board is screwed in, only the fourth one remains. When I was making pseudo-timber for the frame of my ultra-low budget building, I used boards that were much worse than these. I used crooked 6-meter boards that were naturally dried under a shed. That's why I welded cores from metal scraps and inserted them inside the pseudo-timber every meter, and I fastened them to the boards with furniture bolts. The set includes this clever handle. With it, you can get a good grip and drive in long, thick screws. It's actually a really nice thing. By the way, the batteries are compatible with other AID tools, and the screwdriver has a built-in light. This is a professional-grade impact drill driver. The pseudo-timber doesn't warp like real timber. It's almost done, but there's one small finishing touch left. Finally, I go over all 4 sides of the pseudo-timber with an angle grinder and flap disc, slightly smoothing the edges. It really feels like we're looking at a real thick timber beam. That's why I'm leaving a link to the impact drill driver below the video. With it, we can handle not just the pseudo-timber. Along with the self-leveling floor, I also bought something else right away. Thanks to the high plasticity of the mixture and the gravity of our planet, horizontally positioned surfaces are leveled with minimal human involvement. So how can this effect be applied to walls as well? Of course, we can't change the direction of gravity yet so that it affects vertical walls, but we can temporarily give some types of walls a horizontal position. These are exactly the kind of innovative walls, and with a horizontal manufacturing method, were used in my project, the $1,000 House. Regular viewers of the Yasha Koshek Songs channel know that I've been using the help of gravity in my work for a long time. Thanks to this, even someone with absolutely no construction experience can handle making these walls. And if you add a simple leveling operation, you'll end up with walls that are already finished. I know firsthand how much effort it takes to get smooth walls and ceilings using traditional putties. And this option is an incredible money saver. It's perfect for frame panel house construction. To check everything, I started making innovative walls again. But since the leveling layer should noticeably reinforce and strengthen the walls, I decided to make some changes to the usual method. Well, I glue the base of the future walls about the same way as before. Again, I'm using Penaplex Comfort with a thickness of only 30mm and an L edge. I first made the smooth sheets rough using a saw blade for wood that I detached from the handle. I glue the Penaplex with staggered joints. I picked up this phrase when I was invited to a real construction site. By the way, the previous video covers this topic. I'll link it below. Check it out if you haven't already. There I learned how to properly use Penaplex for its intended purpose. The methods I discuss on the channel are mostly experimental, but some of them have already become quite widespread. I use construction polyurethane foam adhesive for gluing. It sets quickly, which is very convenient. I noticed that it's more convenient to glue a large blank out of Penaplex and then cut it into smaller wall panels. I do the precise fitting of the walls to the openings in the frame on site. I want to remind you that in terms of thermal insulation properties, 3 cm of Penaplex Comfort are equivalent to walls made of dry wooden beams 17 cm thick, or to brickwork that's more than 2 bricks thick. In my ultra-low budget construction project, walls with a 3 cm Penaplex core have already been serving for the 4th year, and I'm sure they'll last as long as needed. Penaplex has a service life of 50+ years, outlasting most wooden frames. If budget allows, using Penaplex 510 CME thick is no issue. When making these kinds of walls, I pay special attention to the quality of the fiberglass mesh. I choose a density of at least 155 grams per square meter. The mesh size is 5 by 5 millimeters, and the tensile strength is 1800 by 1800 newtons per 5 centimeters. The higher these numbers are, the stronger the mesh is. Since the fiberglass mesh in these walls serves as a reinforcing material and bears the tensile load, I believe it's not worth saving money on it. I'm mixing the adhesive, which I use to attach the sheet insulation to the surfaces that need insulation and to create a base reinforcing layer on them. I'm starting to form the base reinforcing layer while the wall blanks are in a position that's convenient for all beginners. This ensures the mixture won't fall off, slide down, or miss the target area. The work is simple and easy. Anyone can handle it, whether you're a musician, a teacher, a scientist, or a programmer. Anyone, even those without manual labor experience, who wants to construct the most affordable and energy-efficient walls. Professional plasterers can only work when the walls are in a vertical position. They charge exorbitant prices for their services. By excluding their services from the estimate, we save a lot. I'm using a notched plaster trowel with a tooth size of 10 by 10 millimeters. If you hold the trowel at a 45-degree angle to the surface while applying the mixture, you'll apply about the same amount of mixture. The layer will be even and thick enough. And this is very important for the strength of the future walls, especially for the new version that I have in mind. I use a wide putty knife to give it a final smoothness. In warm weather, the reinforcing layer sets quite quickly, and soon the elements can be carefully turned over. Again, I use plaster fiberglass mesh, and again I apply adhesive compound to the surface of the foam board. I keep in mind that the overlap of one sheet over another should be at least 10 centimeters. But if on the first side I try to apply the layer according to the standard, on the second side I try to apply the minimum possible amount of adhesive. That's why I use the smooth side of the plaster float. I make the layer just thick enough to embed the fiberglass mesh in it. I'll soon explain why I do it this way. For those who aren't yet familiar with the amazing properties of extruded polystyrene foam, which is what Penaplex is, let me explain. The material can insulate foundations, floors, walls, ceilings, attics, roofs, and balconies, essentially the entire perimeter of a house. It's also recommended to lay it under blind areas, walkways, and paved surfaces. And personally, I use it for almost everything as an experiment. Thanks to the thin layers, even without any plastering experience, you can get fairly smooth surfaces that are immediately suitable for applying finishing coats, such as decorative plasters. The reinforcing layer on the other side greatly strengthens the walls through a sandwich panel effect, leveraging structural mechanics principles. But these surfaces themselves can't serve as a final finish yet. Even for wallpaper, they still need to be puttied and puttied. And if you hire finishers, you might end up broke. Since cement-based mixtures take at least 28 days to gain strength, keeping them moist won't hurt at all. I position the wall so that the thinner reinforcing layer is on top, and I prime the surface. The evenness of the floor under the canopy allows you to place the workpiece in the correct horizontal position. Just like in the floor experiment, I foamed the edges with polystyrene. On surfaces this even, I applied almost free finishing coatings that look like brick and natural stone, using the cheapest tile adhesive. But inside a room, this kind of finish is an acquired taste and might seem too rough. It won't suit everyone. I measure out the required amount of water and mix the self-leveling floor compound. I thought that the ultra-smooth surface I achieved while experimenting with the floor is actually excessive for my cheap walls. I tried to speed up the process by putting in even less effort. Now I decided to pour the mixture not in strips, but all at once. After all, I have some experience now. This is my second time pouring. I used a foam board to level it instead of a spatula. The creeping mixture pardons my simplifications. You can support the construction experiments conducted on the Pesniyashi Koshaka channel through the sponsor button on YouTube. Viewers from Russia can do this through a service. The link is under the video. You can also support the folk technologies being developed by subscribing to the channel and leaving a comment. Despite the simplified pouring process, I had only seen such smooth surfaces before when my friend Sergey painted our old patched up Dodge. But back then, my friend put in a lot of effort to make it even. But here, the mixture and the planet's gravity do all the work for us. It saves us money and materials. The riskiest part of this project for me was raising these kinds of walls. Waiting 28 days for them to fully set is an unaffordable luxury, especially for impatient self-builders. That's why I made the bottom reinforcing layer, which will be under tension when lifting, thicker, and the top layer, which will additionally strengthen the self-leveling floor, thinner. Fortunately, despite the noticeable increase in weight, it's possible to lift the wall even alone and even slowly turn it over. The walls have retained their mobility, which means they can be assembled exactly the same way we assembled the first ultra-cheap walls. But now they will immediately have the finished interior side. Everything is working out, and the streamlining is obvious. But we can move on to the next wall. But that was it. Since in my ultra low budget project, it doesn't really matter whether it's a floor or a wall. And when I was experimenting with the test floor at the beginning of the video, I assumed it could also become a wall. Actually, I was experimenting with a wall that, in the worst case, would remain a floor, but everything worked out. The light gray coating of the self-leveling floor on the walls can be left unpainted if the walls are in a garage, workshop, or other loft-style rooms. The coating doesn't produce dust. The color is nice. What more do you need? This way, you can also save on paint, so that no one has any doubts that the walls are really even. I prime them and paint them with the color that reveals flaws on any surface the most: white. The first layer still revealed a few minor flaws. A few grams of putty and a sanding block with sandpaper quickly fixed them. In our main house, the ceilings and walls that I worked on for weeks definitely aren't any better. All that's left is for these walls to be tested by the most important and precise testing laboratory in the universe, time. But relying on my intuition as an intuitive structural analyst, I can predict with 99% certainty that everything will be great with these walls. As far as I'm concerned, the surface is perfect. I think you'll agree with me. You can buy Penoplex at any hardware store or order it online. I'll leave the link below the video. The knee edge shows that the wall now looks like real panel construction. I'm continuing to develop the cheapest construction technology, and improvements like this can be considered an important upgrade. Give a big thumbs up. Subscribe to Yasha Koshik's Songs channel. Follow me on Zen, TikTok, and Instagram. Links are below the video. Hit the bell to stay informed. May peace prevail worldwide. Thank you.